Hey everyone, welcome to this video. Last video we had a look at the list data structure. Today we're going to look at some more data structures and types in Python, such as dictionaries, tuples, strings, and sets. So first we're going to take a quick look at strings. We've seen strings a number of times in Python so far. We can initialize a string by simply putting characters between quotation marks. Strings are similar to lists in a number of ways, but also have a number of differences. The first difference is that strings can only contain characters, while lists can have any data type. Secondly, lists are mutable, which means that we can change the value of a list after we create it. However, strings are immutable. Notice I can index into a string, and it'll give me the character at that index. But if I try to modify a value at an index, so if I say my string at 0 equals b, I get an error saying string does not support items assignment. So those are the main differences between lists and strings. It's worth quickly mentioning another data type, tuples. So we denote tuples with round brackets. And tuples are the same as lists, except they are immutable as well. So again, if I try to assign the letter at index 0 in the tuple, I get the same error but for a tuple, saying tuple object does not support item assignment. Next, we'll have a look at sets. So a set is a type collection which is unordered and unindexable. So the order of the elements doesn't matter. Sets are denoted with curly braces in Python. So let me make a set of fruits. So if I print this set, you can see all the elements. However, if I try to index into it, I get an error saying set object does not support indexing. So since the elements don't have any order, indexing doesn't really make sense. Also, since I can't access items, I can't change them. However, I can add new items. So I can do fruits.add to add a new item. I can also remove an item by doing fruits.remove and providing the value of the item I want to remove in the brackets. Typing fruits again, you can see that mango was removed. Sets also don't allow duplicate items. So say I try to add orange again. You can see that orange still only exists once in the set. Cool, so the last data structure we're going to look at is a dictionary. A dictionary is a collection of key-value pairs where the key and value can each be any type. An easy way to think of a dictionary is that it's similar to a list, but rather than being indexed by numbers 0, 1, 2, it's being indexed by any other type such as a string or a number. An important thing to note is that you can have duplicate values, but you cannot have duplicate keys. Let's initialize an empty dictionary. We can also make a dictionary initialized with some values. So let's make a dictionary for student marks where the key is the student's name and the value is the mark they received. The syntax for this is to have a key followed by a colon, followed by a value, and each key value pair is comma separated. We can now get a value from the dictionary using the key. So if I index into marks using the name Anna, I get the associated value you've returned, which was 72. I can also update a value. So say I want to change the mark for Huss. Now when I print marks again, you can see the value for Huss has been updated. Dictionaries also provide us with functions to retrieve the keys or values. So say I have a marks dictionary. Marks.keys will return all the keys and marks.values will return all the values, both in an array-like structure. We can use these to loop over a dictionary. So say I want to loop over the dictionary and print each of the keys and values. I can type for key in marks.keys and then print the key. And then to print the value, I use the key to index into marks. Running this program over on the right hand side, we can see that each of the key value pairs were printed out. Let's do another quick example to demonstrate how dictionaries can be useful for counting objects. So we'll ask the user to enter a number of fruits, and then we'll construct a dictionary to store the fruit as the key and the number of times that fruit was entered as the value. I've written a little bit of code here to collect input from the user and append each string that they enter to a list. And I've just printed the list here so we can quickly test this code. So it asks for a fruit name. I'll just enter a number of fruits to create some data. Great, so you can see it's printing out our array. Now let's make an empty dictionary called fruit quantities, where the key will be the fruit and the value will be the number of times that fruit appears in the list. So let's loop through the list. And then we'll want to increment the value for this fruit in the dictionary fruit quantities, which would be fruit quantities of fruit plus equals 1. Now we can predict that this is going to throw an error in the case that fruit doesn't already exist in the dictionary. So to fix this, we can add an if condition checking if fruit is in fruit quantities. So if it is in the dictionary, we want to increment it. If it's not in the dictionary yet, we want to assign it a value of 1. Finally, we want to loop through our dictionary and print out the values. Now let's run this program again. As you can see, it's correctly counted the amount of each of the fruits in the list. So that's it for data structures. Thanks for watching.